We're continuing with prepositions and truth tables. We ended the last section by looking at the first 5 logical operators. We're now going to cover the next 4. This table shows the last 4 logical notations that we will cover in this section. Now, let us look at a slightly more complex example, implication. Implication prepositions are if-then preposition. In this example, if the sky is blue, then the ocean is blue. The implication P implies Q is false when P is true and Q is false. Another way of thinking of implication is if P, then Q. Pause the video and try constructing an implication table on your own. Here is what our completed implication truth tables look like. Notice that P implies Q is false when P is true and for Q is false. Recall that the last column tells us the truthfulness of the expression. With our example where P is it's raining and Q is it's cloudy, then the P implies Q is as follows. Row 1, if it's raining, then it's cloudy, this is true. Row 2, if it's raining and it's not cloudy, this is false. Row 3, if it's not raining and it's not cloudy, this is true. And row 4, if it's not raining and it's not cloudy, this is true. Let us now look at biconditional statements. Biconditional prepositions connect statements such that P is true if and only if Q is true. The biconditional is the preposition that is true when P and Q have the same true value and is false otherwise. Pause the video and try constructing the biconditional truth table on your own. Note again that a biconditional statement is true when P and Q have the same truth value as shown on this table. This is when both variables are true and when both variables are false. Take a moment to study this if you do not get it right away. Now, let us move on to universal quantification. The universal quantification set is represented by the upside down A, and X represent members of the set. This example is the set of all letters of the alphabet that are going to be considered. A universal quantification sentence says that for all X in the universe of discourse, which just means the set of all things we want to talk about, the subset PX is true. For example, for all X in the English alphabet, the letters in the set P are true because they're a subset of the universal set. Let us consider this example. Let us say that we have a universal set that contains all teachers. If we assign teachers variable X, then we take a subset P of a teacher and another subset Q that is Y's. What then would this statement mean? This is what it means. The upside down A means for all X. If X is a teacher, then all X's are Y's, or all teachers are Y's. Can you answer this statement? If X is a girl, then all girls are human. That's the correct answer. Next, we will look at existential quantification. We use the notation E facing the opposite side X and PX, which can be read, there exists an X in P. In the previous example, we saw that the universal quantification, we're working with all members in the universe of discourse, all the sets we want to talk about. By contrast, in the existential quantification, we work with the understanding that there exist some members. So, the existential quantification says there is an X such that PX, or there is at least one X such that PX is true. The existential quantification of a predicate Px is the proposition there exists an x in the universe of discourse such that Px is true. If we say that Px means that x is university student and Q means that x is genius, then what does this expression mean? It means that at least one of the university students is a genius. There exists an x such that x is a university student and x is a genius. The next example we'll take a look at, let us say that the universe discourse is made up of all real numbers. What then does this expression mean? In our example, it means that for every x, there exists some x such that x plus y equals to 200 is true. We can also have a counterexample in universal quantification. The statement, all birds fly, is disproved by counterexample of penguins. In this section, we reviewed how logical operators work when we combine preposition statements and how truth tables help us to visualize the result of these combinations. We also reviewed the universal and the existential quantification. These concepts are important, fundamental part of discrete math. So feel free to review this video again to make sure that you have a solid grasp on this before moving on.